So good day, guys. Welcome to this class. And in this class, we are going to be solving all the problems and exercises in this electrostatics. So we are going to start from example. We call this example 1.1. And what we have here under example 1.1, it says that the charge on a particle is the charge on a particle is 2 times 10 raised to the power minus 4. Determine the charge quantum number. In this case now, the charge, remember the symbol for charge is Q, right? Is 2 times 10 raised to the power minus 4 coulomb. And what you are asked is to determine the charge quantum number. That is N number. Now, what is the relationship between N, Q? It's given by Q, right? Is equal to N, E. What we are looking for is N. And we know that E is a constant, right? The value for E, we have already established that the charge of the electron is 1, right? 0.602 times 10 raised to power the negative of 19 coulombs, right? So if we plug it into this formula, all we have to see is that we'll have this Q now will be equal to 2 times 10 raised to power minus 4 equal to N times 1.602 times 10 raised to power minus 19. If we make N the subject of formula, what will happen? This whole value here will be divided by this value. So we now have N to be equal to 2 times 10 raised to power 4 all over 1.602 times 10 raised to power minus 19. And the value, the answer you will have is equal to 1.248 times 10 raised to power 15. That's our answer. Okay. Let's go to the second example. I think this is very easy. It's just, but we are still on static charge. But let me talk a little bit more of current electricity. Current electricity is the flow of charges, right? So when charges are at rest, it's called electrostatic. And when charges begin to move, it's called current electricity. Example 1.2 here. Example 1.2. Example 1.2. This example states that lightning occurs, right, when the flow of electric charge between the ground and thundercloud. The maximum rate of flow of charge in a lightning bolt is about 20,000 coulomb per second. Now, rate, right? Rate, just listen. It's about 20,000 coulomb per second. So, what do you see there? Coulomb, 20,000 coulomb per second. So let's continue. It lasts for 100 microseconds. So what we see there is time, right? So the T is equal to 100 nanoseconds. How much charge flows between the ground? So what are we looking for? Charge. So what we have here, if you don't know the unit for this, it's very easy. Since you are saying coulomb per seconds, right? What does it tell you? That means that this charge, are you getting it now? See, the symbol for coulomb, that is the symbol for charge, is Q, right? Q, right? Replace it with the symbol. The symbol for S, that is seconds, is time, right? So it means that Q over T is equal to 20,000, right? So what are we looking for? Charge, sorry, not C. It's still the same thing. C is the unit. We are looking for Q. So in this case now, make use of the formula. Q will be equal to 20,000 times T, right? And what is T? T is same thing as 100 microseconds. And if value for the micro here is 10 raised to power minus 6. So if you press your calculator here, what you are going to have, you press your calculator here, is 2 coulombs. 2 coulombs. So the number of charge here example 1.4. What we have here, the question says that what is the magnitude of the coulombic force between 2 point charges? So what are we looking for? Force, right? Yes, force is what we are looking for. Between 2 point charges, Q1 equal to minus 2.0, right? Microcoulomb, and Q2 is equal to plus 3.5 microcoulomb, separated by a distance of 15. So what we have here, arrow, is the distance, separated by a distance of 15 cm. Converting 15 cm into meter, that is 0.15 meter, right? In air. In air. So when they tell you air, you know that we are using our normal permittivity of free space, that is K, is it not? Because for air, K is equal to 9 times 10 raised to the power of 9 Newton meter per coulomb square. So using the general equation, or using general formula, F to be equals to KQ1 Q2 all over arrow square. When we plug in to this point, K here is 9, right? That becomes 9 times 10 raised to power 9 times, what's our Q1? 2. We ignore the sign. We are not going to write minus 2 there. That is 2 times, because micro there, the micro there is 10 raised to power minus 6. So that is 10 raised to power minus 6 times Q2 is 3.5. So that is 3.5 times 10 raised to power minus 6, right? All over arrow square. Our arrow is 0.15 all square, right? So when we press our calculator and plug in the values, we'll have when we press our calculator and plug in the value, we'll have F to be equal to negative, it's no negative. When we plug in the values, we'll have F to be equal to 80 Newton. That's the answer. Now, if they ask you what is the nature of the force, that is where you consider the sign. Recall that like terms attract, right? Plus and plus, are they like terms? No. So what will they do? They will repel. Minus and minus, are they like terms? No. What will they do? They will repel. Only what attract are unlike terms. What are unlike terms? Plus, minus, or minus, plus. In as much as they are unlike terms, they will attract. Unlike terms will do what? Attract. So when we get to this question, this is minus and this is plus. Are they like terms or unlike terms? Obviously, they are unlike terms. So what will be the nature of the force? Attraction. Are we getting it now? If that is correct, let's go to the next question here. The next question here we go to is example 1.5. And the example 1.5, what we are talking here, what we want to say here is, it says two identical coins. If you don't have the question, you can write this down. Two identical coins. My God. Oh God. Two identical coins separated by a distance of 2.5 meters. So that means that here arrow is equal to 2.5. Are we getting it now? Yes. In a large vase of liquid carrying identical charges, are you getting it now? So you say that two coins are separated by a distance of what? 2.5 meters. And those two coins are in a large vase of liquid. Are you getting it now? Which are carrying identical charges. If the dielectric constant of the liquid is, this is where we're going to use dielectric constant right now. If the dielectric constant, are we getting it now, of the liquid is 92. If the dielectric constant of the liquid is 92. Now note that dielectric constant and relative permittivity are the same thing. So it means that in this case, ER is equal to 92. Are we getting it now? Calculate A, the magnitude of the charges, if the repulsion force is 42. So they have given you the force F to be equal to 40. And they are asking you in I, you are being required to calculate what? The magnitude of each charge. Recall from Coulomb's law that F is equal to K Q1 Q2 over R square. But in this case now, our Q1 and Q2 are equal, right? So that means that F, let's say Q1 and Q2 are equal. So if Q1 is equal to Q2, and we can call them Q, let's say both of them are Q. So we can say that F is equal to K Q square over R square. What are we looking for? They ask you to calculate the magnitude of their charge. So we make Q, solve the formula. In this case, Q becomes what? Take this to this side. That becomes F, right? R square. This will now come down, right? Become over K. This square becomes square root, right? So that becomes the square root, right? So in this case now, we substitute the value. Substituting the value, what is our F? Our F is 40, right? Times, what is our R square? Our R is 2.5. So that's 2.5 square all over. Now, what will be our K? What will be our K? Now, note this down. When you are given a new constant of permittivity, another shortcut, remember that we said before that when you are given a relative permittivity, all you just need to do is to say E, right, is equal to E naught A arrow, right? Then substitute to K. But there's another shortcut, and that is K is equal to K naught over epsilon arrow, right? Yes, I think this is shorter. And how do we derive this? This is very easy. You can derive this. So, what is our epsilon naught? Our epsilon naught is the normal constant of permittivity. That will be 9 times 10 raised to power 9, right? All over, what's our epsilon arrow, right? Relative, that is 92. So in this case now, this is what we substitute here. We will now substitute in here. We now substitute in here, right? 9 times 10 raised to power 9 all over 92. So you can evaluate this in your calculator like this, and you will have an answer like approximately 1.6 times 10 raised to power minus 3. I mean approximately. That's the answer. Then it asks you for the number of electrons. It's very easy. Recall that this is the charge that you got, right? So you can do the number of electrons by yourself when you know that N is equals to Q over E. Q is equal to 1.6 and the value for electron is 1.6 times 10 raised to the power minus 19. Substitute here, we have the answer. If that is true, let's go to the next example. I think everything here is easy. Let's talk about example 1.8. Example 1.8. Example 1.8. Example 1.8 is very, very easy, right? Sorry. Example 1.8 is very, very easy. What we just need to do is to apply the principle of physics. That's why the principle of basic physics can never be underrated in the study of physics. In this case, it says that two tiny balls, my God, of mass 1. So the mass here is 1.5 kg. We are on example, right? 1.8. Two tiny balls of mass 1. So m is equal to 1.52 mg. I'll get it now. What is that mg? Milligram. Listen very carefully. So they are trying to test your knowledge on conversion here also. Suspended from a common point by a light insulating thread. It says that the thread is 20 cm long. We begin to use this one, begin to sketch the free body diagram. If they are assumed to be point charges of equal values that repel each other until they make an angle of 15 degrees with the vertical. So what do? We imagine a vertical, right? Let's say this is the vertical plane. Then the two threads, they repel each other. So this is thread 1 because there are two light bulbs. And this is thread 2, right? Yes. So they repel each other and they make an angle of 15 degree to the vertical. Are we getting it now? Yes. So let's continue. So let's say these are the point charges. This is the point charges. Are you getting it now? Okay. So calculate the charge on each ball. To do this, what we need to understand is that the electrostatic force here, we are going to use the knowledge of vectors. The knowledge of vectors is where we are going to use now. So how do we get the electrostatic force? First of all, we already know that mg will be in this direction, right? Yes. That is the weight of the body will be pointing downward. So this is weight of the body. This weight mg we are talking about is different from this mg. This one is milligram. This one is weight. So I would like to call it weight so that you won't confuse it, right? The weight of the body always acts vertically downward. Now, where will the force be going? Now, let's assume that we already know from the question that they repaired themselves until they got. So that means that charge 1 was here before, right? charge 2 was here. They began to repair themselves. They began to repair themselves until they got to this position, making an angle of 15 degrees. So it means that the force is acting to this side, right? The force is acting to the horizontal directly this way. This force is along this side for them to repair. So that means that in this place now, F will be around this axis, and F here will be along this axis F, and this will be W. If we are correct, that implies that then the tension on the string, you can just, what will be the tension on the string? It will be along this side, but we don't need the tension to calculate for the force. What we are required to do is to calculate for the charges. So to calculate for the charges, this is the logic. We remember that F is equal to K Q1 Q2 all over what? R square. And they say they are identical charges. So that means that Q1 and Q2 are equal. So they become Q square, right? And F here can be gotten from the free body diagram here. Are we getting it now? Yes. It can be gotten from the free body diagram here. So what we just need to do is to calculate the value of F. And when we calculate the value of F, we substitute here and we have our answer. So first of all, we need to calculate for the weight of the body. And we discover that weight is equal to mg. Why are we calculating for the weight? We'll ignore that later. First of all, if I take away this free body diagram here, remember the resolution of vectors when we were in primary school. If I take away this free body diagram, I want to form a closed triangle from this point. I want to form what? A closed triangle from this point. I already know that my F is along the vertical, so I will call this F, right? Then my weight is along, my F is along the horizontal. My weight is along the vertical, that is W, so I'll take it like this, right? So my tension will be along this axis, and my angle remain 15 degree. Are we getting it now? So how can I get this force here? How can I get the force here? Recall that this weight is equal to mg. So here, are we getting it now? Here, our mass, that is m, is equal to what? 1.5, right? 2. They already give us m in milligram. So we have to convert from milligram to where? To kilogram, not gram. So first of all, to convert from milligram to gram is 10 raised to the power minus 3. Then converting from gram to kilogram is another minus 3. So the total exponent will be 10 raised to power minus 6, right? Then your gram will now be 9 times 8, 1. So pressing your calculator, that will give you 1.5 times 10 raised to power minus 5. So that will give you 1.5 approximately times 10 raised to power minus 5. So what will be on this axis now, I can just clean here because I hope you understand the process of how we got it. What will be on this axis now, this force here is 1.5 times 10 raised to power minus 5 Newton, right? So we just need to use our trigonometry to bring the force effect to this side. So how do we do that? Using SOHCAHTOA, this is opposite, right? This is opposite, this is hypotenuse, and this is adjacent. So what is the relationship from SOHCAHTOA? From SOHCAHTOA, you see, those things have to be in your fingertips. So what is the relationship between the opposite and the adjacent? Let's look for it. Opposite, adjacent. That is tan theta. So from here, tan theta is equal to, and our theta is 15. So tan 15 is equal to our opposite. So our opposite is is F. F over our adjacent, that is 1.5 times 10 raised to power minus 5. I will get it now. So make F subject of formula. Make F subject of formula. F will be equal to tan 15 times 1.5 times 10 raised to power minus 5. So when you press your calculator, you discover that when you press your calculator here, you discover that 1.5 times 10 raised to power 5 minus 5 times the tan of 15 should give you what? 4.0 times 10 raised to power minus 16. So that is 4.0 times 10 raised to power minus 16 Newton. Having this, we can now solve effectively for the charge. But before that, we need to calculate the distance of separation. How do we get the distance of separation? We can also use Pythagoras theorem. Now, in this case, now we are not using it in terms of force, but first of all, let's keep our force somewhere. Let's keep it our force somewhere. Our F is what? 4.0 times 10 raised to power minus 16 Newton. So let's solve for the distance of separation now. The only value they gave us in distance is the length of the thread, right? This is the length of the thread given to us. So there are two ways you can solve this. You can use sine rule, or you can also use um right angle triangle. But I will love to use the right angle triangle because I just like the methods. But you can actually use both. So first of all, in this case now we are not considering the force, we are considering the length, right? So they told you that the length of the thread is how many cm? They said the length of the thread is 20 cm long. So this means that from here to here is what? 20 cm. So this is 20 cm. So what do we do? How do we use it to calculate this? To calculate this 20 cm, we already know that arrow is the distance of the separation, right? So it means that from here, like from here to this side, that means from here, sorry. I mean from this point to this point is arrow, is it not? But if we are considering only this place because we want to solve with only this length now to get this side should be what? Arrow over 2 is like half, right? So using that, we can use that and go back to our Pythagoras theorem to get the value of arrow. So this is 20 cm. This remain our 15. And this become arrow over 2, right? Using SOHCAHTOA, this is opposite, right? This is what? Hypotenuse. So that becomes the saw, is it not? Because SOHCAHTOA. Are we lying? So we are using the saw, OH, opposite hypotenuse. So our opposite, so that is sine, right? 15 is equal to our opposite is arrow over 2 all over our hypotenuse is 20. So make arrow subject of formula. That means arrow over 2 is equal to 20, right? Sine 15. Or arrow is equal to 2 times 20 sine 15. So 2 times 20 sine 15 is 10.35. Are you getting it now? It's 10.35. So here, that means our arrow is 10.35. That's in cm. 10.35 cm. So what do? We have gotten our arrow. We have gotten our force. So we can now solve So since we got in our arrow and we got in our F, we can now solve for the force, right? 10.35 as our arrow, and our force is 4.10. So that arrow, which is equal to 10.35 cm, converting it to meter is divided by 100, right? So that becomes 0.035 meter. Am I lying? No. So recall that F is equal to KQ1 Q2 all over arrow square. Our Q1 and Q2 is equal to Q. It's the same thing. So we can say that F is equal to what? KQ square over arrow square. So what are we looking for? Our Q. So making Q the subset of formula, Q becomes the root, right, of F arrow square all over, all over K. Are we getting it now? If this is true, then we substitute. We cannot substitute easily. What is our F? Our F is 4 times 10 raised to power minus 16. Our arrow is what? 0.0135 all square, right? And our K here, we already know that it is free space. It's 9 times 10 raised to power 9. So when you evaluate everything in your calculator, you will have a final answer. You will have a final answer to be equal. If you evaluate everything here in your calculator, you have a final answer as Q to be equal to 2.18 times 10 raised to power minus 9 coulombs. That's the answer. Thank you very much. God bless you. In the next video, we are going to be solving all the assignments. If you find this useful, please share to your class group, your friends, and anyone you wish to pass this course having A and flying colors. God bless you. I am Ojo Fortune, aka Pastor Physics.